With us today, we have three researchers. We have Josh Fisher with Chapman University, Kerry Cawse-Nicholson from JPL, and Ileana also from JPL. They will be taking you through the data and as well as how to, use all the software and data files and whatnot to do your mapping. So, yeah.
All right, great. Thank you, Jane, and thanks everyone for coming. My name's Kerry, I'm the science lead for EcoStress, and Josh is the science lead before me, and thanks to Ileana for coming to help as well. So I'm going to give you a very quick introduction, and then I'm going to hand it over to Josh. He's going to walk through some of his lecture notes, basically helping you learn how to use the data, and then feel free to actually test out some stuff on your laptop or watch me do something on my laptop and see if that's helpful to you. So EcoStress is mounted on the International Space Station, and it looks down at Earth measuring surface temperature. So what you would feel if you actually touch the ground or the roof or the top of the tree. And from that, we can study all kinds of things. We can understand how plants respond to heat, how their water use changes, how urban heat impacts populations, and many more. So urban heat in particular is one of the examples that we'll show today. And urban heat waves in general are actually the deadliest natural disaster. They kill more people every year than earthquakes, hurricanes, everything else, because there are a lot of people who may have pre-existing conditions, they're exposed to this excessive heat and prolonged heat. And when you look at the rates of people who've died on average versus people who've died during heat waves, that number is significantly higher. So it's something that we want to address. And as an example, we've been working with the city of LA, who are trying to mitigate that urban heat. And so they're painting the streets with a special paint that stops the heat from being retained in the streets, and it cools down the whole neighborhood. It's been such a success, they've rolled it out in Phoenix as well, hundreds of miles of these painted roads. And that's just the beginning of what we can do. So we've had some interest from journalists in using EcoStress before, and they've been really successful. I don't know if Washington Post folks know Kevin Poe. Yeah.
Well,
Yeah, so
well, I don't know if they remember, but I worked with them.
Yeah. So he's been using our EcoStress data, used it in a couple of stories. There was one story about migrant crossings. So people coming over the border through the desert, and many of those people don't actually make the journey because of that excessive heat that they're exposed to in the desert. And so having the EcoStress temperature data enabled him to paint a picture of the conditions that people might be exposed to and exactly how hot that sand might be. Another story he did using one of our airborne instruments was looking at heat in schoolyards. And so it kind of blows my mind that in Southern California, where I live, the kids play on asphalt. And that, can you imagine how hot that gets? So that's where you put the kids to play. And he did a survey on how impactful that is and what is being done to improve that situation. And so now I'm going to hand it over to Josh. He's going to tell you how you can also access the data.
Okay, go on. Okay, works. Awesome. Cool. Thanks. So thanks, Kerry and Jane. So I'm Josh Fisher, professor at Chapman University. I was at JPL for about 12 years, and the founding science lead for EcoStress before moving to academia and spinning off the space company. So one of the things that I've done now at Chapman is really figure out how to teach what I did at JPL to students. So I've got a whole class, which is, this is actually based on a project called Ice Cream, because if there's one thing I learned from NASA, it's how to come up with convoluted acronyms. And so this project, which I proposed to NASA for funding, it deals with helping students learn how to use EcoStress data to address science, track climate disasters around the world, whether it's these heat waves or fires or droughts or whatever is going on, and communicate it back to the media, such as you guys. So we have journalists come in and teach the students how to communicate, and we have artists also teach them how to do design and data visualization. So the class is really designed to be picked up without any kind of prior experience. So hopefully today, you guys can be my students, and we'll see how it goes. And I've got some great teaching assistants that will help you figure out what you clicked incorrectly and how to restart your computer when it crashes, etc. So come for the ice cream, stay for the data.
Ready?
I can. All right. Okay. Yeah, works. Oh, okay. Yeah, there we go. So the question that kind of we were trying to pose is how do we move beyond the classic, like a scientist gets some data, downloads it, analyzes it, publishes in a journal that takes a year to review, finally gets out, and everyone's long since forgotten about that event that they looked at, that El Nino, whatever it is. And so how can we do this fast? Like there's a fire that hits, can we grab data from the space station, bring it down, visualize it, put it out on social, put it out on traditional, whatever it is. So like, can we do this fast? And how do we empower the next generation to do this in a way that's meaningful and inspirational? And so, as mentioned, there's like this disconnect between this disaster happening, and then you get proposed for funding, and then the publication, and there's just this disconnect that we're trying to throw off these barriers. And so we're really trying to just be like, okay, there's a massive heat wave sweeping through Phoenix. Let's map it out. And this was a map that one of our undergrads from Chapman did through an internship this summer at JPL, where she was looking at these streets are getting so hot that the red indicates that you'll get like a 3rd-degree burn. And so she was able to produce that quickly, get it out. And so we're really trying to drive the cadence of climate communication, right? Because, you know, climate change, climate science is doing its thing, media is doing its thing, but can we like really bridge them so they go hand in hand? This is another example of a bunch of fires in California that Drought and Moranci, one of my former interns, picked up and communicated as well, back through Jane's office at JPL. So using the NASA traditional media. And we're also trying to increase the diversity and representation of those who communicate these disasters through this. So there's a whole DEI angle to this project. So there's communication components, data visualization components as well. So we've got this class, here we are teaching the class, the students. And we have this website, it's called observingearthfromabove.com, where we put all the materials, all the teaching materials. And so you can go to that right now, and there's these tutorials that show you how to go through some of the stuff we'll do right now, and more. There's videos that talk about the lecture and the theory of like some of the data sources and applications. And other teaching materials for professors who want, you know, example syllabi and Canvas pages and things like that, and then some other information. So we're just gonna jump right into it because time is short. And so if we click on the tutorials page, you'll see a bunch of these tutorials. There's like a dozen of them, and you can see they're kind of each about 30 minutes to take. We designed them like modular, so professors can insert them into different classes. And so they're like 30-minute tutorials. We're gonna take a few bits from the first few, just so you can download data today and make a map, just to have that satisfaction and kind of end to end. But the tutorials cover all the different data products that EcoStress produces, from temperature to drought products to how much water plants are using. Lots of different things EcoStress does. The tutorials themselves are divided up into a table of contents with objectives, kind of an inspirational piece, and then kind of steps to get through and some homework assignments. So these are all the tutorials. We're going to start getting through some of them right now.